Welcome back to Mastering Analog. In this video, we will be discussing the solution to problem number 2.3 of chapter 2 of the book Design of Analog CMOS Integrated Circuits by Behzad Razavi. In this problem, we are asked to derive the expression for GM-R0, which is the intrinsic gain of a transistor in terms of ID and W over L. We also need to plot GM-R0 as a function of ID for different values of L. Note that lambda is inversely proportional to the length of the channel. Lambda is the channel length modulation coefficient, and it is always inversely proportional to the channel length. So longer the channel, smaller is the channel length modulation coefficient. Again, as I mentioned in my previous videos, there are three expressions for GM, and it is good to memorize them as it helps during design process. Here I have listed the expressions for GM for two different cases. When lambda equals to 0, that is, we are ignoring the channel length modulation effect, and when lambda is greater than 0, that means we are not neglecting the channel length modulation effect. Since we need to derive GM-R0 in terms of ID and W over L, and I see that there is W over L and ID in this expression, I'll be going ahead and using this expression for GM. Also, R0 can approximately be given as 1 over lambda ID, and since lambda is inversely proportional to 1 over L, I can remove the proportionality by introducing a proportionality constant. So lambda is equals to alpha over L. Now substituting the value of lambda here, we get R0 is equals to L over alpha ID. Now we need to just go ahead and multiply GM with R0 and see what do we get. So GM-R0 is under root 2 mu n Cox W over L ID times L over alpha ID. If I bring this term into the square root, then it will be L square over alpha square ID square. Now 1 L cancels with 1 L, 1 ID cancels with 1 ID, and regrouping the constants together, we have under root 2 mu n Cox over alpha square times W over LID. If I write all of the constant as K, then GM-R0 is basically K times under root W over WL over ID. Alright, so this is the expression for GM-R0 in terms of ID and W over L. Now, in order to plot GM-R0 versus ID, how do we do that? There is a general trick for you to plot anything. So the way you do that is you plot the extremities first. So let's say ID. When ID is equals to 0, so the denominator of this term is 0, so GM tends to infinity. So when ID is 0, GM is tending towards infinity. Alright. And again, the second extremity is when ID is tending to infinity. So when ID tends to infinity, GM tends to 0, right? Because the denominator is tending to infinity, so GM-R0 tends to 0. So when ID is tending to infinity, GM tends to be 0. So you have this extremity and this extremity, all right? And since this is a square root term, the behavior will be exponential. So you will have this behavior. All right, now we need to plot for different values of L as well, and since L sits in the numerator here, a higher value of L gives a higher value of GM-R0 for a given value of ID. So for a given value of ID, a higher value of L gives a higher value of GM-R0. So higher the value of L, higher the value of GM-R0 for given ID. Alright. So this is how it will look like as you increase the values of L. So here we have L3, L2, L1, and L3 is greater than L2 is greater than L1. Alright, this is the simple solution for problem number 2.3. In the next video, we will be discussing the solution to problem number 2.4. Thank you for watching.